Have you ever wondered what keeps our solar system together? The answer is the sun, the heart of our solar system. The sun, a colossal ball of glowing gases, reigns supreme in our cosmic neighborhood. Not just any star, it's a giant among dwarfs, holding the title of the largest object within our solar system. In fact, it's so massive that it makes up a staggering 99.86% of the solar system's total mass. To put that into perspective, you could fit 1 million Earths inside the sun, but its significance extends far beyond its size. The sun is the ultimate powerhouse, fueling life on Earth with its radiant energy. It lights our days, warms our planet, and even powers the photosynthesis that plants need to grow. Delving deeper, the sun is a hotbed of nuclear fusion, where hydrogen atoms constantly collide and merge to form helium. This process releases a tremendous amount of energy, which radiates outward as heat and light. But what about the other planets in the solar system? How does the sun affect them? Well, this is where the concept of gravity comes into play. The sun's hefty mass creates a strong gravitational field that pulls everything towards it. It's this force that keeps the planets, including Earth, from hurtling off into the vastness of space. Instead, they remain tethered in their orbits, like marbles swirling around a bowl, forever circling the sun. So, the sun, with its immense gravitational pull, keeps our solar system together. It's a cosmic lighthouse, the heart around which all else revolves. It's the source of our days and seasons, the engine of life, and the celestial body that gives our solar system its structure and rhythm. But the sun is just the beginning of our journey through the solar system. There's a whole universe of wonders waiting to be explored beyond this fiery beacon. As we delve deeper into the cosmos, we'll encounter rocky planets, gas giants, and icy worlds. So, the sun, with its immense gravitational pull, keeps our solar system together. But what's next after the sun? Closest to the sun, we find the 4 rocky planets. Let's start our journey with Mercury. Now, Mercury, our solar system's smallest planet, is a world of extremes. It's the closest to the sun, and yet, due to its lack of atmosphere, it experiences the most significant temperature swings in our solar system. It's a place of blistering days and freezing nights, with a surface pockmarked by countless craters from meteor impacts. Moving along, we encounter Venus, the second planet from the sun. Despite its serene appearance, Venus is anything but. It's the hottest planet in our solar system, with surface temperatures high enough to melt lead. Its thick, toxic atmosphere is filled with carbon dioxide and cloaked in sulfuric acid clouds. Its surface is a volcanic landscape, with thousands of volcanoes scattered across its face. Next, we arrive at the third rock from the sun, our very own Earth. It's the only planet we know of that harbors life, thanks to its just right distance from the sun and its protective atmosphere. It's a world of diverse landscapes, from the highest mountain to the deepest ocean trench, and it's home to an array of life forms that is as spectacular as it is varied. Our last stop among the inner rocky planets is Mars, the red planet. It's about half the size of Earth, and its rusty surface gives it a distinctive red hue. Its thin atmosphere of mostly carbon dioxide, combined with its distance from the sun, makes it a cold and dry world. But don't let that deter you. Mars is a planet of wonders, with the tallest volcano and the deepest, longest canyon in the solar system. These rocky planets, each with its own unique features, are the inner neighbors of our solar system. But what lies beyond these? Beyond Mars, we encounter a vast ring of debris known as the asteroid belt, and beyond that, the gas giants. This is the asteroid belt, an expansive ring of rubble that circles the sun between the orbits of Mars and Jupiter. It's composed of metallic and rocky substances, with some asteroids even boasting their own moons. Despite the many space movies depicting dense asteroid fields, the reality is that these space rocks are often hundreds of thousands of miles apart. Asteroids are the remnants of the early solar system, pieces that never quite came together to form a planet. Their study, offers a glimpse into our cosmic past, a sort of time capsule that scientists can use to understand the formation and evolution of our solar system. Beyond the asteroid belt, we meet the gas giants, Jupiter and Saturn. Known for their size and gas-dominated composition, these planets are truly a spectacle to behold. Jupiter, the largest planet in our solar system, is more than 11 times the diameter of Earth and is known for its iconic Great Red Spot, a storm that's been raging for centuries. Saturn, the second largest planet, is famous for its breathtaking ring system, composed of countless particles of ice and rock. These rings stretch out more than 200 times the diameter of the planet itself, a truly awe-inspiring sight. Each of these gas giants boasts a significant number of moons. Jupiter, for instance, has 79 known moons, including Ganymede, the largest moon in the solar system. Saturn, not to be outdone, has 82 known moons. These gas giants, with their numerous moons and rings, dominate the outer solar system. Yet, there's still more to explore. So buckle up as we venture further into the mysteries of our cosmic neighborhood in the next part of our journey. Further out, we meet the ice giants and the mysterious Kuiper Belt. Our celestial tour brings us next to the ice giants, Uranus and Neptune. These behemoths of the outer solar system are aptly named for their chilly temperatures and massive icy cores. Uranus, the seventh planet from the Sun, is often referred to as the sideways planet due to its unique tilt. It's almost as if it's rolling around the Sun on its side. Neptune, the outermost planet, is a world of fierce winds and monstrous storms. Its deep blue color is a testament to its frigid climate, and it holds the title for the planet with the strongest winds in the solar system. These winds can reach speeds of up to 1,500 miles per hour. Beyond the ice giants lies the Kuiper Belt, a vast frontier filled with icy remnants from the dawn of our solar system. This region is home to Pluto, once considered the ninth planet and now classified as a dwarf planet. But don't let the term dwarf fool you. Pluto has 5 moons of its own, with the largest, Charon, being just over half its size. The Kuiper Belt is also home to countless other dwarf planets and celestial bodies, all remnants of the early solar system. These icy bodies are like time capsules, preserving the materials and conditions of the solar system's infancy. The Kuiper Belt also serves as the boundary of our solar system, marking the edge of the Sun's influence before we venture into the interstellar space beyond. From this far out, the Sun is just a bright star in the distance, a reminder of the journey we've taken from its fiery surface to the icy outskirts of our solar system. And with that, we've journeyed from the Sun to the outer edges of our solar system, a journey of billions of miles. From the fiery Sun to the cold, distant Kuiper Belt, our solar system is a place of wonder and mystery. This whirlwind tour has taken us from the heart of our solar system, the Sun, to the far reaches of the Kuiper Belt, truly a journey of astronomical proportions. We began with the Sun, the star at the center of our solar system, whose gravitational pull keeps everything in perfect harmony. This massive ball of hot, glowing gases is the primary source of light, heat, and energy, not only for our Earth, but for every celestial body that orbits it. Then we ventured to the inner rocky planets. These are Mercury, Venus, Earth, and Mars. Each of these planets has a solid, hard surface with mountains, valleys, and craters, a stark contrast to the gaseous Sun. They're closer to the Sun, hence receive more of its heat and light. Our journey continued to the asteroid belt, a disk filled with millions of space rocks orbiting the Sun between Mars and Jupiter. This belt serves as a kind of cosmic demarcation line between the inner rocky planets and the outer gas giants. Speaking of which, we then explored the gas giants. Jupiter and Saturn, colossal planets composed primarily of hydrogen and helium, just like our Sun. Their size and composition make them distinct from their inner, rocky counterparts. Next, we ventured to the ice giants Uranus and Neptune. These distant worlds are composed mainly of ices, such as water, ammonia, and methane, hence their name. Finally, we reached the Kuiper Belt, the outermost region of our solar system, home to icy bodies and a number of dwarf planets, including Pluto. This cold, distant region serves as the frontier of our known solar system. As we've seen, our solar system is an incredibly diverse and intriguing place. There's always more to discover, so keep looking up and let the stars guide your curiosity.